Now let's take a look at page 2. You do not necessarily need this worksheet to do the work. You can record your information in a notebook and do all your calculations in that notebook. Let's take a look at our graphs, problem 6 and problem 7. You can see that each graph is clearly proportional. We start at 0, 0, the origin, and the line is completely straight. So in each case, we already know that a proportional relationship exists. However, let's take a closer look. We're being asked to find the unit rate for each graph. So here's my suggestion. Anytime you're given a graph and you're asked to find a unit rate, it's important to organize your information. Let's create a small t-table next to the graph. It doesn't have to be very big. We don't have to prove the graph is proportional. Now, we know X and Y mark the tops of each of these columns. But what does X represent? Well, let's take a look. Our X represents the number of cars. And then our Y values, well, that's the number of people. So Y is a people number. Now we only have to grab a few readable points off the graph. Let's just quickly grab this point and maybe this point. Let's think about what these points really represent. 2 cars can hold 12 people. And this point, 5 cars can hold 30 people. Let's set up a ratio for each one of these ordered pairs. Remember, when we set up our ratio, it's going to be Y over X, or people over cars. So 12 people can fit in 2 cars. 30 people can fit in 5 cars. Now let's reduce each of these to simplest form. We can divide a 2 out of each of these to get 6 people per 1 car. And down here, we can divide a 5 out of each of those to get 6 people to every 1 car. In fact, if you look for your unit rate that states 6 people per 1 car, that unit rate lives right here, 1, 6. That's our unit rate. That's our amount per 1. Now pause your video and look at graph 2. Create a t-table exactly the same way as you did for number 1 along with me, or actually number 6, and create some ratios from that t-table. So start by creating a t-table, set up your ratios, and then reduce to get your unit rate. When you're done pausing the video and finishing this problem, you're going to move on to the next section. And remember, when you're completely done, you can check your answers against the answer key I've provided for you. Remember to show your work in your spiral notebook or on the worksheet if you were able to print it. Pause the video and finish this problem. When you're ready, let's move on to the next section. For problems 8 and 9, we've been given a table of values. Now, for these tables, they would like us to find the unit rate for each. Well, let's take a look at problem 9. It seems to be a little bit more difficult than problem 8. You can do 8 later on your own. X stands for the number of pounds, and Y stands for the cost in dollars. And as you look at this table, you see some mixed numbers. And that can be a little daunting as you look at the mixed numbers because sometimes they're not easy to work with. But in this case, we have a little trick we can use. We can convert each of these to their decimal equivalent. For example, this half, well, we know it's equal to 0.5, so really, let's use 2.5. And then many of you have this equivalent memorized. We know 3/4 is really equal to 0.75. So we can express this value as 3.75. Now we're ready to set up our ratios for this particular table. Remember, we're going to set Y over X, or in this case, we want to find out the cost, and our X is pounds per 1 pound. That will give us the unit rate. So in your notebook, write $10 per 2.5 pounds and $15 per 3.75 pounds. Now, it's not easy to reduce these, so we're not going to try. We're actually simply going to divide. Grab your calculator and divide 10 divided by 2.5. And once you get an answer, try and punch in 15 divided by 3.75 when you get a chance. You should have gotten an answer for both of these as 4. But you need to dress it up with labels, and that's going to take us back here. What does that 4 really mean? It means $4 per 1 pound. Now that's the unit rate. Take a moment, pause the video, and do the same for table number 8. Remember, you're going to put Y over X, cost over tickets, as you create your ratios. Pause the video, and remember, you can check your answers against the answer key later. And lastly, what happens if you're given an equation and you're asked to find the unit rate? Well, we know the unit rate and the K rate are almost the same thing. Remember, K times X equals Y. So you will find that K rate right in front of that X variable. It's the coefficient. So we know that in the first case, 2.75 is our K rate. That's going to be very important. And in our second problem, 15 1/2 is also the K rate. K times X equals Y. So in each case, we know those numbers are going to be very important when we dress it up with units, when we dress each number up with units to get our unit rate. But here comes the tricky part. Giving that number meaning or dressing it up with units. Remember, when we calculate those ratios, we put Y over X. And in this case, it would be C, cost, over P, which is your X in this case, pounds. So as we dress up this number with labels, to give it some meaning, it really means $2.75, our cost, per 1 pound. And that is your unit rate dressed up with units. So in this case, in number 11, you're going to put y over x, which m, or your y, is miles, and your x, or your h, represents hours. Take a moment and dress this number up with units to create a unit rate. When you're done with all of these problems, check your work against the answer key. This concludes page 2 for the day.